So this is the first presentation on the longitudinal HLM, and this is also called by many people growth curve modeling. So we will be spending 3 weeks on this, and we'll get started with an overview. So as you see here on the slide, we will be getting started in week 1 with an introduction to growth modeling, which is this presentation. This includes equations and basic modeling approach to longitudinal data, and there will be an exercise in using HLM7 to run a growth model analysis. So this is the first introduction. Then week 2, we're going to look at investigating trajectories. So we're going to look at how can we look at longitudinal data before we actually run growth models. And then we'll talk about how to build and assess models. Things are a little bit different. Things are a little bit more, I think, exciting. We will talk about notation and interpretation of 3-level models. Because when we start week 1, we're going to just talk about multiple measurements within people. So it's quite an individualistic approach, and then we're going to move forward into integrating a 2-level model with actually growth modeling. And then week 3, I will introduce you to time varying predictors, so predictors that change over time as does the outcome. And we will also talk about nonlinear change. And then we'll talk about centering time, which is a little bit different from centering other variables. So lots of exciting things to come. So we will now talk about growth modeling. So we have nestedness of a different kind. I had mentioned this earlier. So now we're going to talk about multiple measurements are taken for each participant. And so we have within participant dependency that we need to account for. And as we all know, within person dependency is usually high if I am looking at things such as depression. We know that previous issues with depression predict future issues around depression. If we look at people's any kind of habits, there's a large relationship between what people did yesterday and what they're going to do tomorrow and even a month from now, because we're habitual creatures. So if you have multiple measures on a person, unless you only have pre and post, you cannot run a regression analysis. So for longitudinal HLM, what we need is at least 3 measurements or more for at least some of the participants. And I mean exactly what I'm saying. And some is relative, so obviously it can't just be 5 people with 3. But the idea is that we're actually investigating trajectories. And so if you have 2 points, all you can do is draw a straight line. And if you want to estimate something, you need at least 3 time points. So that's what we're going to be talking about. But what this also means is that when we're going to talk about longitudinal HLM, you can have some of your participants have only 2 measurements and some of your participants only have baseline data. And we will talk about this. And this is a prime example for what we call full information maximum likelihood estimation that allows us to deal with missing data points on the outcome. And this is quite exciting as well. So step 1, as always with anything, you need to explore your data. Now, this gets way more interesting because now we have multiple data points. We will spend time on this in the second week, and there is an extensive SAS code, and there's actually code for other data packages available as well, and that will help to graphically represent in other ways to explore the data that you have, so that you can actually make some good judgments in terms of planning your model building, but also then assessing any kind of findings you have. So most often people simply assume, or at least start with a linear change over time. A lot of behaviors actually change in a linear fashion, and if we only have 3 data points, that's actually the only thing we can investigate. There's nothing else we can do much with that. So we are going to see 2 unconditional models in growth modeling. And so the first one is the unconditional means model. And that is the equivalent of your unconditional cross-sectional model. So the first one, it has no predictors in there. It only describes and partitions the outcome variation, just the same way we've been doing it in cross-sectional data. Now, there is new notation because everything shifts up a level, and this comes from the idea that actually multi-level modeling came out of individuals nested in structures. And so then the measurements were kind of a level underneath people. And it's actually, if you would be using M+, it's interesting if they talk about a 2-level growth model, they actually talk about what I would call a 3-level model. So it would be measurements nested in people, nested in some kind of clusters. And so the notation now is actually that our outcome, which is measured multiple time points, and there's a pi notation here now, and then the betas are going on level 2. And so looking at this level 1 and level 2 equation, instead of having a gamma in the mixed equation, now we have a beta. And this is, all of this is Singer and Willett notation, which if you haven't done so, read that. If you're doing any kind of longitudinal data analysis and are serious about this, I would strongly recommend getting the book. The first half is exactly what you will need and exactly what we'll be covering in this class. The second half talks about survival analysis in not in a multi-level context though, but it is a really good book, and I know from several students that it's very approachable, easily digestible for students. So the unconditional means model, and that stipulates nothing in there, that there's no change over time, and so the one only has an intercept. So this would be usually not what we're looking for, but it models no change over time. It also stipulates that participants can have some error around a flat trajectory. So no change over time is flat, and then but people can hover around, and that's our level 1 error. But then the model also stipulates that the flat trajectories may differ in elevation between people. So that's our level 2 error. So now in terms of interpretation, the beta 00 is the average elevation across the population. So the average value over time across the population. And we will use this model to calculate the ICC. Now, what you will see is that ICCs are quite different in magnitude because now we have people at level 2 and we have measurements at level 1. Now, the second model you will run is the unconditional growth model, and that includes only time or anything that represents time. So it could be age or something like this. It could be the wave of data collection, anything in that sense, but that's the only predictor that happens at level 1. So here's a notation. So we're adding a level 1 predictor here. So we're having now a notation of YTI, which is the measurement time and individual. And it looks just the same as the others, but we're going to use the beta notation. So the mixed equation gets you into beta 00. So the average intercept plus an average slope. And then there are the 3 error terms, the variation around the intercept, the variation around the slope, and then variation within person. So this slide outlines this in detail again. So the beta 00 is your average intercept. So the average value of the outcome at time 0. We're going to talk about centering week 3, but right now we're assuming that we're starting at a certain point. So let's say we have an observational study. So the first time point baseline usually gets coded as 0. And beta 10 is the average slope, so the average change in the outcome over time, for example, per year, per month. We'll talk about scaling. It's really important to do this well for interpretability. ETI measures how much a person's score, person I score, at the measurement occasion T at a certain time deviates from this person's growth trajectory. So how much of noise does a individual person have around his or her trajectory. So each person will get a trajectory. Each person will get a starting point and an estimated change over time, but we know that the measurements will not be exactly on that line, but they will be scattered around. And that's sigma squared, which is the variance associated with ETI. And that's really how much scatter is around their own change trajectory. Then we get the R01 and the the R0I and the R1I, R0I and R1I, which are associated with tau 00 and tau 11. Tau 00 is the inter-individual variance of the intercept. So what's going on in terms of variance in this sample at time equals 0? How much variation is there? And tau 11 is the variation around the slopes. So how do people differ over time? How much is there going on average? They're changing, let's say, with they're taking 100 steps more per week. But how much is there going on in terms of variance with that change over time? So those are the interpretation of those individual parameters. So I want to talk for the first time about how to build a growth curve model. So remember, a good model includes all necessary predictors and no unnecessary ones. If you have predictors that shouldn't be there, that's usually less of an issue, but we've talked about power and random effects and all those decisions you have to make. So there is more impact in a multi-level model and in a growth model than in a regression model. And if you're missing predictors, then we have a problem too. And this is a bigger problem because then you're misspecifying. If you have an unnecessary predictor, it strains your power. It could cause some modeling problems. But if you're actually missing out on including something, you might not get good model fit. And so we want to choose again on 3 criteria. And so substantive theory, your research questions, and then statistical evidence, because we again have to actually see what the data tell us, and that goes back to measurement and other things. So you can't model something where you don't have any variance, for example. That just doesn't work. So model building again. Singer and Willett recommend entering level 2 predictors simultaneously into the intercept and the slope equations. That might not always make sense in case of an intervention, but you really want to think about this. I don't know what this next comment is supposed to mean. First, add question predictors. Oh, sorry. Now I get it. So the first thing we want to add are the focal relationship predictors. What are you actually interested in? So let's say the question is, are there different trajectories for men and women? Then adding the gender into your model would be your first predictor after the unconditional means model and the unconditional growth model. And then you would add control predictors, anything that you might consider either being a confounder or something that is just added to models in the literature regularly. And that would be your next step. And we'll be looking at this in the in-class exercise. Now, how can you talk well about your results? And I'm going back to what we've done when we talked about moderators. So how can you talk about moderators? You will actually start using prototypical points. So what is important in growth modeling is that we will illustrate prototypical change trajectories. And this is much easier than dealing with interaction effects because people think about change over time in these trajectories. So if you want to talk about your results, it makes sense to actually graph prototypical change trajectories. The reason I started talking about the moderators is because you kind of do it the same way. So let's say we have a dichotomous predictors, for example, men and women. Then you create prediction equations. You substitute each of the values and you display both those trajectories. In an equation or in a graph, I would strongly recommend doing it in a graph. Most people digest graphs much faster than equations. Now, with continuous predictors, we have different strategies. You can use substantively interesting values. So cut points for weight, for example, you can categorize people um, who are at the lower end of normal weight, overweight, obese, and things like that, and therefore have trajectories for BMIs of 18, 25, 30, 35, 40, for example. Another way is use of a range of percentiles. 25th, 50th, 75th percentile would be three trajectories you can actually show. Some people might go with 10th, 50th, and 90th percentile, but that depends on your research question, what the field is kind of interested in. Some people you could use a sample mean and then a half or full standard deviation, or even two standard deviations apart. So somebody who's kind of on the edge of a normal distribution, the 95% range. Or you can just use the sample mean. And that would be it. But that's a little bit boring, I would argue. So depending on your research question, it makes a lot of sense to think about who are different groups of people or what are different criteria of people that would make sense to show a prototypical change trajectory. So this is it for the first lecture on growth modeling, and I strongly encourage you to read the chapters by Singer and Willett carefully, and then we will meet in class.